It's maths time, year 5. So let's have a look and see. We are carrying on with using our different methods of multiplication to multiply by one digit. We did 2 digits on Monday, we did 3 digits yesterday. Today, hopefully you can guess, we are going to be multiplying 4-digit numbers by 1 digit. Now, it's exactly the same process, just we have a thousands column to contend with, which means that for some of our answers, when they get larger, we're going to have a 10,000 column to contend with as well. It's the same process, excuse me, and we're using the same 3 methods to prove our answers. Well done to all of you who are proving your answers using at least 2 of the methods. Really shows a much deeper understanding, so well done. So first of all, let's have a little starter activity. Alex and Dexter have both completed the same multiplication, which is 236 times 6, but they've got 2 different answers. Can you pause the screen? First of all, who is correct? And second of all, to really show that deep understanding, have a look at what they've done. Can you work out what mistake the person who's incorrect has made? So pause the screen, have a go with that, and then I will reveal all. Okay, so let's have a look. So that is correct. The answer is 1,404. Hopefully you noticed that Alex has forgotten to add the exchanged hundreds. So we know that 3 times 6 is 18. Add the 2 tens that were left over, sorry, which gives us 20. So there's 2 exchanged, 2 that need to be carried across. 2 times 6 is 12, add the 2 is 14. So she needs to have remembered to do that. So hopefully you guys managed to spot that. So same as we did yesterday, but this time we are going to be looking at tens, hundreds, and thousands when we're multiplying. So what sort of vocabulary might we be looking for? So to multiply means to add equal groups. So we're looking for lots of, repeated addition, product of, groups of, timesing, and multiples. And that gives us a few different ways that we could work out as well. So going to start off with 6,518 times 6. And here are some different ways that you could see or hear that question being written or said. So that could be said as 6 lots of 6,518. 6,518 plus 6,518 plus 6,518 plus 6,518 plus 6,518 plus 6,518. Starting to wish that I had just you to read that one. The product of 6,518 and 6. The 6th multiple of 6,518. 6 groups of 6,518, 6,518 times 6, or 6,518 multiplied by 6. And that number no longer feels real in my mouth. So there's loads and loads of different ways that you might see that question or you might hear that question. All of those mean the same thing. It means that we're multiplying. So we're going to start off again with our classic column method. Then we'll go into partitioning. Then we'll go on to our visual representation. And then we'll do the same with another set of numbers. And then I'll set you your activities. So the product of 8 and 6 is 48. Now 48 has got 4 tens and 8 ones. So 8 ones goes in there. Our 4 tens get exchanged and move across to the 10. 1 multiplied by 6 is 6. Then I have to add the 4 tens that we had left on. So that leaves me with 10. That has 0 ones and 1 10. So the 0 stays in our answer and the 1 gets carried across. The 5th multiple of 6 is 30. Add the 1 gives us 31. And 6 lots of 6 is 36. Then add 3, which gives us 39. So the product of 6,518 and 6 is 39. 39,108. That's our classic column method. Let's have a look at our partitioning method. So I can partition 6,518 into 6,000s, 500s, 110, and 8 ones. So I'm going to do that, and I'm going to do my 4 calculations. So I'm going to do 8 times 6 first, which is 48. 10 times 6 is 60. 500 times 6. If 5 times 6 is 30, then I know that 500 times 6 must be 3,000. My apologies. That's not particularly good. I did say in the SPAG video that I am very much fallible, but 500 times 6 is 3,000 because we add those extra 2 zeros onto our answer. So 6 times 6 is 36. Then 6,000 times 6 will be 36,000. So let me just check that I get that one right. Yeah. Then what I need to do is I need to add all of these together. Have I done that at the bottom? So 8 plus 0 plus 0 plus 0 is 8. 4 plus 6 plus 0 plus 0 is 10. 0 plus 0 plus 1 that we carried is 1. 3 plus 6 is 9. And 3 plus 0 is 3. So we end up with 39,108, which gives us the same answer that we got from our classic column method. It's a good way of checking as well, because if I had carried on where I only had 300 as my answer here, and then went to check, I could see that I got a different answer on both methods. So I'd have to double check my work. Finally, let's have a look at our visual representation. So I need to make 6,518 first of all out of my counters. I've got my place value grids. So I've got 6,000s, 500s, 110, and 8 1s in my grid. Now I need that 6 times. So I'm going to end up with 6 rows of it. 1, 2, 3, 4, 5, 6 lots of 6,518. Hello, Miss Lee. I am, but that's okay. Now, what I can do is I can start counting up what I've got there. I'm going to start with my 1s, and straight away I can see I've got too many 1s there. I can only have a single digit in the 1s column. So I'm going to count up my 10 1s because they can be exchanged for 110, and I'm going to bring them across. Now, I was on 48 there, so 40 can be exchanged for 4 10s, which leaves me with 8 1s. Now my 10s, I have got exactly 10 10s. Now I can't fit 10 in the 10s column, so that's going to have to be a 0. 10 10s is the same as 100, so I'm going to exchange that for 100. With my hundreds, I've got 31 hundreds. Now I can't have that in the hundreds column, so I know that 30 hundreds is the same as 3,000s. So I'm going to exchange that, and that leaves me with 100. Now with my thousands, I have got, how many have I got? 39 thousands. Again, it's too many to fit in my thousands column, so I'm going to take 30 thousands and exchange them for 3 10,000s, and that leaves me with 2, 4, 6, 9,000, and I can clearly see that I've got 3 10,000, which gives me 39,108. So all 3 methods have given me the same answer. So I can be confident that the product of 6,518 is 39,108. Now we're going to have another go with 3,446 times 4. What I'd like you to do though is I'd like you to pause it with at the start of each method, try it yourself, and then see if you got the same thing that I got. You can also follow along to see if you didn't, what changes what did I do differently? So pause it here, have a go at that one in that method first, and let's have a look. So the product of 6 and 4 is 24. So I've got the 4 up there and the 2 gets carried. 4 multiplied by 4 is 16. Add the 2 is 18. The 4th multiple of 4 is 16. Add the 1, which gives me 17. And 3 lots of 4 is 12. Add the 1 gives me 13. So the product of 3,446 and 4 is 13,784. Pause it again. Have a go at using this method this time instead. You should know what the answer is by now, so hopefully that will help you with the process. You can almost work backwards. Okay, so I'm going to partition 3,446 into 3,000s, 400s, 4 10s, and 6 1s. 6 times 4, I know is 24. 40 times 4, I know that 4 times 4 is 16, so 40 times 4, I add an extra 0 onto that, which gives me 160. 400 times 4, I know that 4 times 4 is 16, so I add 2 extra zeros on, so hopefully that should give me 1,600. There we go. 3,000 times 4, 3 times 4 is 12, and 3,000 times 4 is going to have this 3 extra zeros. I should end up with 12,000. Now I'm going to add all of those together. 4 add 0 add 0 add 0 is 4, 2 add 6 add 0 add 0 is 8, 1 add 6 add 0 is 7, 1 add 2 is 3, and 1 add nothing is 1. So 13,784. Let's just double check. Is that the same answer I got there? Brilliant. Chances are I've probably got it right, but to prove my really deep understanding, I am going to show it using that place value grid as well. First thing I need to do is make 3,446. After that, I know I need 4 lots of that. That's only 1 lot of it. So let's get our 1, 2, 3, 4 lots. And we can see it's 3,000s, 400s, 4 10s, 6 1s in each column. I've got to count them up. I've got too many 1s to fit in 1 column, so I'm going to exchange 2 lots of 10 1s for 2 10s. That leaves me with 4 1s left over. In my 10s, I'm going to exchange 10 10s for 100. Ooh, I've got a rogue 1,000, which leaves me with 8 10s left over. Then my hundreds, I am going to exchange 10 hundreds for 1,000, which leaves me with 700s. In my thousands, I'm going to exchange 10,000s in that beautifully drawn little box for a 1/10,000, which leaves me with 3,000s, and I've got 1/10,000. So again, I've got 13,784 in my answer. So again, what your job is to have a go at using two of the methods. That's to find the answers to these questions. Some of you are not challenging yourself as much as I would like you to be. So try to make sure that you're having a go at some of the word problems as well and the open-ended question at the end. So I'll go through, it'll be the arithmetic problems first, do lots of word problems, then your challenge, and then I'll go through the answers for each one. Again, if you have any problems or if you get any answers different to mine and you're not sure how you've got them, then please do email me and I'm happy to send in a bit more detail how you get the answers. So there are your arithmetic questions. Pause the slide here for them. There's your first batch of word problems. There's your second batch of word problems. Remember, guys, the word problems are meant to go together. So if you're doing the word problems, that is still 6 questions. They just didn't fit on one slide very easily. And there's your challenge as well. You'll find 3 possible solutions for this one. Okay, so let's run through some answers. Here are the answers to your arithmetic sums. Here are the answers for your first batch of word problems. Here are the answers for your second batch of word problems. And for your challenge, here are the 3 answers that I was able to find. We know that A must be 1 because A times C still leaves us with C, but B times C doesn't leave us with B. So C's not 1, it has to be A. We also know that there must not be any exchanging here because we get the same answer for each time. But that's how I managed to get these answers. You guys may have found a different answer to me. If you did, then do send it over to me because I do like trying to find new things here. But these were the sums I could find that had no exchanging and had C being the same in each one. Hopefully you guys enjoyed that. Next week, we're going to be looking at multiplying by 2 digits this time. So we'll be using similar processes, but it's really important for you to keep practicing your times tables because that will really help you with all that we are doing here.